All right, here we go. Quite a section 3.5 is, and there's a fair amount of notes that goes with it. You know, we can bust this up. We're going to have a couple assignments with it. So even though the notes are long, there's a bunch of valuable information in them. And there's no other way to do it. So 3.5, graphing, linear equations in slope-intercept form. In slope-intercept form. And we have been introduced to slope-intercept form already. Remember back in section, or on your quiz in 3.3, you had to identify equations and tell me if they were linear. And we wanted to see if they looked like y equals mx plus b. And that equation, y equals mx plus b, is slope-intercept form. Mathematicians are very fancy, very fancy. Why do we call it slope-intercept form, y equals mx plus b? Because we can tell a y-intercept and we can tell a slope right from the equation. Y equals mx plus b. Memorize it, say it, know it. M is my slope, b is my y-intercept. Y-intercept, where it crosses the y-axis. And hopefully you remember back to yesterday, my y-intercept will always have an x-coordinate of 0. 0. So it's where it crosses the y-axis. We're going to dive heavily into this. It's going to be what we're, this concept of slope and y equals mx plus b is the next handful of weeks of your life. We're going to look at slope in general, and I am going to make 4 very basic, simple coordinate planes. I'm just going to start out by making all of my y-axis. And now I'm just going to make x-axis is on all of these. I will label them. And there I go. I got 4 coordinate planes. We're just going to talk about slope. If I put that line in there, we are going to determine whether we have 4 types of slope. We're going to have positive, negative, 0, and what we're going to call undefined. And to tell if the slope, or identify what type of slope I have here, I read this graph left to right. When I look at this line and I go from left to right on the x-axis, this line is rising. It is going up. Y's are becoming more positive. My y's are getting bigger. This has positive slope. And I can tell if the slope of a line is positive or negative by just looking at the graph. If it's rising as I read it left to right, it's positive. I'm sure you can tell me if I have a line that is falling as I read it from left to right, it's going down, this slope is negative. We graphed these yesterday. I have a horizontal line. Hopefully you can tell me that this is the line y equals something. This has 0 slope. And we are going to get into why this has 0 slope. And I could have a vertical line. the line x equals something going through a point on the x-axis. This vertical line has what we call undefined slope. And this vertical line has always got something funky going with it. Remember, we were telling, when we were determining whether these were functions, every line was a function except for a vertical line. It did not pass the vertical line test. I've got all the same input right here. And this slope is kind of funky. It's what we call undefined. I always thought of these as roofs. I definitely would want a roof that's an A-frame, something that covers me like this. The roof on the middle school is a horizontal roof. It's a flat roof. It would certainly protect me from the rain, but I would not want a vertical roof over my head. Undefined. I don't want it. What does this slope mean? And if you think of the word slope, hopefully ski slope pops into your mind. Hill, incline, it's how fast up or down I'm going. Or maybe I'm not going up or down at all. Slope is the rate between any 2 points, on a line. It has a constant rate of change. We figured out our rate of change from our tables. When we found out, when I gave you a table of values and asked you if it was a line, you looked for a constant rate of change. Was the change in x the same as the change in y? If that ratio was the same, I knew I had a line. The rate between it is going to be constant. You're not going to have a line if I am going up a hill and then this, and then I go down, and then I go back up. That is not linear. These parts of these are linear, but if I put it all together, it's not a line. The rate that I go up here is positive slope, then I go to zero slope, then negative slope, then positive again. The rate of change is not the same. Slope is for just a single line. And I can choose any 2 points on that line, just like we did in the XY table. And I know my rate of change will be the same. I know that's linear. Slope. And we are going to call this M, just because of y equals mx plus b. Some of us knew this in the lecture this morning for my in-person. It's my rise over my run. It is how fast up I go divided by how fast over I go. It's my change vertically divided by my change horizontally. My change in y over my change in x. Change in y because I am going up and down first. It's my rise divided by my run. We are going to call this rise over run. I can call it change in y divided by my change in x, because your rise is associated with your y-axis, how fast up you're going, divided by your run, how far left or right you are going, the change in your x. I'm going to abbreviate this and you will see this all over. Triangle y, triangle x. This triangle is a Greek letter, and it is delta. And delta means change. This is change in y over change in x. You'll see this all the time in science as well. You'll see delta T, a change in temperature. You will see delta P, a change in pressure. Here we're going to use delta Y, the change in y. And if I say change, if I say I weigh 210 pounds, and now I weigh 200 pounds, my change in weight is 10. How did you get that? Well, you subtracted them. right? You subtracted them. The change is subtraction. It's the difference of them. In the book and in literature, and if I send you Khan Academy videos or something, you will see this slope. You will see this formula. This y2 minus y1 over x2 minus x1, this is my change in y over my change in x. You're taking differences of any 2 points that lie on the line. So I'm going to have 2 points. They both will have y values. I subtract them, and then I divide them by subtracting my x's. And we're going to do plenty of these. What do you need to know for now? Slope is rise over run, and it's change in y over change in x. I am going to flip my paper over, and I am going to make some coordinate planes here, or look at some examples, and we're going to figure out some slope. So what I have here first example, I'm going to draw a little coordinate plane here, and I don't have to be, I want it to look good, but I don't have to be terribly accurate, because I am going to just count rise over run, and then I'm going to have some points. I'm going to make this go down a little bit deeper though, and when I'm making coordinate planes here without graph paper, which I can certainly do, I still label it x and y. Then on my y's, I tend to use my horizontal lines here, right? Because they're nice and spaced out. So I'll say that's -1, that's +1, -2, +2. On my x's, I'm just going to eyeball it, splitting it evenly from the origin, how many spots that I want on it. It's not terrible. It will work for what we're doing. I'm going to put a couple of points on here, and I will label them. I will call this the ordered pair -3, -2, because that's where it's sitting. And I will put one out here at +3, +2. I am going to connect those and make a line, and we are going to figure out the slope of that line. We're going to figure out the change in y over the change of x. We are going to figure out the rate of change. We're going to figure out the constant rate of change. You will always be able to figure out the slope of a line given 2 points on the line. When you are given a graph and asked to find the slope, my go-to method, I'm going to do this 2 different ways. I'm going to do once with rise over run, and then I'm going to do it with change in y over change in x, which is the same thing. I'm just going to go about it differently. When you are asked to find the slope and you're given a line in a graph, I can visually see it. My go-to is to use m is equal to rise over run, because I can simply count the change in y, the change vertically, and divide it by the change horizontally. If I look at this right here, this line rises as I read it left to right. My m is going to be positive. How do I get from -3, -2 to +3, +2? Well, aren't I going up this way? There's my rise, and then I go over. This is my rise. This is my run. Rise over run. How far am I going up to get to this point? Well, if I'm at -2, I'm at -1, 0, 1, 2. My change in my y to go from -2 to +2 is 4. My run is to get from here over to the point. Well, if I'm at -3 and then I go to +3, I am going over 6. And notice, this is positive slope because I am going up in the y direction. I'm getting positive. I am going to the right in the x, where x is positive. That's what makes this positive. 4, 6, you will miss a point because that is not reduced, gives me 2/3. There's my slope, a positive 2/3. A rise of 2, a run of 3. Hopefully you're thinking to yourself, couldn't I go this way as well to get to that point? You certainly could go down and over, and I want you to think about that. Now my rise in this direction, to get from here to here, I'm not going up, I'm going down. I am going -4, and then when I go to the left, I am going -6. But what's a negative divided by a negative reduced to? It gives me a positive, and then I reduce it, and I still get 2/3. That's finding slope using rise over run given off of a graph. You can also take any two ordered pairs, and it gives me ordered pairs that lie on this line. -3, -2 is an ordered pair, and 3, 2. And a lot of these problems are going to be given this way. It will say the negative, it won't even give you the graph. And if I just gave you these points and said, tell me the slope, you certainly wouldn't want to graph these and then do rise over run. Too much time. This is where I use change in y over change in x. And I can certainly use change in y over change in x given this graph. I just find it easier to count. Here's what we do to find slope. M is your change in y divided by your change in x. And here's how I handle these. I always circle my y's. There is subtraction between them because it is a change. Here's my y's. And if I go back to that formula on the first page, I could say this is y2 and this is y1. The point being is when you see that y2 minus y1, you are subtracting the y's. I am always going to go left to right. And be careful. If you go -2 minus 2, when you do your x's, you have to go -3 minus 3. I can't go -2 minus 2 here and then take 3 minus a minus 3 here. I have to go ordered pair to ordered pair. 2 minus a minus 2. I'm sorry, that's a -2. So -2 subtract 2, and then I would divide it by, I got to go in the same direction. -3 minus 3. Now I certainly can go in this direction. I could go 2 minus a minus 2, but then I would have to go 3 minus a minus 3. It's going to give me the same thing as long as I go in the same direction. I am always going to circle my y's and then work left to right with subtraction. -2 minus 2 divided by -3 minus 3. Now I just do the math. -2 minus 2, -4, -3 minus 3, -6, which reduces to a positive 2/3. And hopefully you're seeing, if I went in this direction, it would be 2 minus a minus 2, which is a positive 4, 3 minus a minus 3, which is a positive 6. You're going to get the exact same thing. You're just not going to have the negatives there. It's going to give you the same slope, no matter which way you do it. So get another example here, another quick XY coordinate plane. Here's my X, here's my Y, and again, I am going to use the horizontal lines here on my Y-axis. Sorry, that's my X. That's my Y. That's terrible. Here's my Y, here's my X. I will just split this up right here. Gonna put some points on there. This is gonna be the ordered pair 2, -1, and I will go up to the ordered pair 0, 2. I am gonna connect those with a line, and again, you are going to be asked to find the slope. If I look at this, and I look at rise over run, you should be thinking right now, because this line is falling, your slope will be negative. It's falling as I read it left to right. I'm going to do it both ways. Rise over run. Which way do you want to go? Well, I could go this way. I could certainly go this way. Or I could come right down here and go this way. I could go either way. My rise, if I look at my change in my y's, I'm going from -1 to +2. 1, 2, 3. You are going up 3. It is a +3. But now I am going to the left 2. That's where the negative comes in. That's why this slope is negative. A rise of 3, a run of 2. That gives me a -3/2. And I certainly could have went the other way. This is a rise. Now to get from here, I'm going down 3 and to the right 2. The 3 is now negative, but it doesn't matter where I put that negative. It can go in numerator, denominator, but the point being is that you will get -3/2 either way. You could also do change in y over change in x. And again, circle your y's. I've got a y here and a y here. I'm going to go -1 minus 2 divided by 2 minus 0. -1 minus 2 is -3. 2 minus 0 is 2. And I get the exact same thing. Hopefully we're starting to pull this together. Doesn't matter what 2 points lie on the line. This slope is always going to be the same. My rate of change is constant. You've got a constant rate of change. Finding slope from a table. Finding slope from a table. When you are given a table, they're always going to tell you it's a line. These points lie on a line. And when it tells you that they are linear or they lie in a line, you know you are going to have a constant rate of change. So here's letter A. I'm just going to make a vertical XY table. Give you some values of X. We will go 4, 7, 10, 13, 20, 14, 8, and 2. And you're going to be asked to find the slope, the rate of change, the change in Y divided by the change in X. Notice, 4 to 7 plus 3, 7 to 10 plus 3, 10 to 13 plus 3, 20 to 14 subtract 6, 14 to 8 subtract 6, 8 to 2 subtract 6. You definitely have a constant rate of change. Now we've got to find the slope. Now you've got to find the slope. Well, the easiest way to find slope given a table is to just do change in y over change in x. Because what's my change in y? Well, it's -6. What's my change in x? That's a +3. What is -6 divided by 3? It's going to give me a -2. That's my slope, -2. You could certainly choose any 2 points on this line. What points do you want to choose? I don't know. Let's do this one. Let's do 420 and let's do 13.2. Any 2 points would work. I could use any combination of these points. But if I choose 4-20 and I choose 13, 2, x of 4, y of 20, x of 13, y of 2, you can certainly do change in y over change in x and subtract these out. Circle your y's. 20 subtract 2 divided by 4 subtract 13. Do the math. 20 minus 2, 18. 4 minus 13, negative 9. Look at that. 18 divided by negative 9, I get the exact same thing. When you were checking to see if you had a constant rate of change in section 3.3, we were really setting us up to find this slope here, to find out what the change in y is divided by the change in x. And you can see where this slope comes from, I hope. Let's look at letter B. Got an x and a y. Negative 1, 1, 3, and 5. And I'm going to say these are all 2. Hopefully you are recognizing right now when all my y's are the same and my x's differ, you have a horizontal line. Horizontal line has a slope of 0, and here is y. If I do my change in y over my change in x, to get from negative 1 to 1, I add 2. To get from 1 to 3, I add 2. To get from 3 to 5, I add 2. To get from 2 to 2 is 0. It's not changing, it's 0. The change is 0. Remember, slope is equal to change in y over change in x. What's your change in y? Is it changing? No, it's not. It's 0. Doesn't matter what the change is here because 0 divided by anything is 0. Doesn't matter what 2 ordered pairs you choose. Aren't you always going to have for your change in y 2 minus 2 in your numerator? Your change is always going to be 0. This is why horizontal lines have 0 slope. There is no change in the y. And if I think about a horizontal line, you are not changing vertically. You're not going up or down. Your change vertically is 0. 0 is in the numerator of change in y over change in x. It is 0. Hopefully you see what's coming next. We're going to look at this vertical and why it's undefined. Let's say my x's are all the same value. Hopefully you can tell right now. It doesn't matter if all my x's are the same. You have a vertical line. A vertical line. My x's are the same. My y's are negative 3, 0, 6, and 9. And you can see that you are adding 3, adding 6, and I'm adding 3 here. Why are these different? Well, I'm going up by 3 here, and then I go immediately to 6. I could choose any point for y, doesn't matter. What's my x always going to be? Negative 3. What I want to point out to us is that when I do change in y over change in x, let's say I put in here, let's say I put in positive 3. You're still going up 3, right? And then to get from 3 to 6, up 3. So your change in y is 3. Your change in x is now, though, 0, because it's not changing. And when you put into your calculator 3 divided by 0, it ain't 0. It tells you it's an error. We cannot divide by 0. When we see 0 in the denominator, and we've mentioned this several times this year, we say this is undefined, and that's where that slope comes from, is undefined. There is no change. There is zero change horizontally. There's a vertical line. It's not moving left or right. That is undefined because the change is zero. Okay, moving on. Getting ready to do some graphing. I would definitely have a sheet of graph paper for this. You don't necessarily need one. I'm just going to do this in there. And we are going to look at graphing, identifying, looking at equations, and starting to use the slope-intercept form to graph. So what we have, what I'm going to title these, is just slope-intercept form. Slope-intercept form. And we're going to graph with this. When you see slope-intercept form, we always got to be thinking we're dealing with y equals mx plus b. M is my slope, b is my y-intercept. Let's jump right into some examples. Letter A, here's an equation. Y equals